In the name of Allah. In this lecture, we will discuss how to calculate the cost of electrical losses in transformers, or in other words, we will explain the equation used to calculate the cost of electrical losses in transformers. Of course, this topic is one of the most important subjects for professionals involved in the procurement of transformers. We will try to present this topic in a very concise manner, but for those who require more detailed information, it can be found in the International Standard Specifications, Standard IEC 60076 Part 19.1. Of course, if you need to purchase a new power transformer, the first step in the process of procuring a power transformer or any electrical equipment in general is to define the specifications of the required transformer. For example, the frequency is 50 Hz. The rated power of the transformer is 40 megavolt amperes. The transformation ratio of this transformer will be, for instance, 66 kilovolts to 22 kilovolts. The vector group is DYN11. The magnetic flux density is less than or equal to 1.6 Tesla. The noise level is less than or equal to 73 decibels, and so on, including the rest of the technical specifications required for the transformer, in addition to the general and special conditions such as the delivery period, delivery location, and so forth. Let us assume that the transformer will be procured through a tendering process. In that case, the required technical specifications and the general and special conditions will be sent to companies or factories specialized in manufacturing transformers. After that, we will wait for the offers submitted by these transformer manufacturers. Of course, a comparison will be made between all the required technical specifications as well as the general and special conditions and the offers submitted by the companies. Let us assume that the companies or offers submitted which meet all the required technical specifications and the general and special conditions are, for example, two companies, Company A and Company B. This means that both Company A and Company B fully comply with all the transformer specifications. Naturally, as everyone knows, after completing the technical evaluation of the submitted offers, the company will be selected based on the price of the transformer. As we can see here, the price of the transformer or the value of the offer submitted by Company A is 31 million Egyptian pounds, while the price of the transformer offered by Company B is 30 million and 800,000 Egyptian pounds. Of course, the offer from Company B is cheaper by 200,000 Egyptian pounds, and therefore the transformer will be selected for purchase from Company B since it offers the lowest price. However, this approach and the procurement process in this manner is extremely risky because up until now, the cost of the losses for each transformer has not been calculated. It is very important to know and understand that this transformer will be installed, for example, in a substation. Therefore, we will be receiving, purchasing, or importing electrical energy from generation companies and power stations, and we will then transmit or sell it to consumers and distribution companies. Of course, we must also understand that a portion of the electrical energy that we import or purchase from the generation companies and power stations will be lost within the equipment of the substation, specifically within the transformers at the substation. Naturally, the electrical energy that is lost is something I am paying for, and thus it represents a financial loss for me. That is why it is extremely important to determine the cost of the losses or the cost of the electrical energy lost within the transformer, and to know exactly how much this cost will be over the course of 1 year. From this, we understand that one of the most important steps in the process of purchasing power transformers is calculating or determining the cost of losses for each transformer, of course, after reviewing the technical specifications of the transformer. Therefore, we must understand that the total own cost, TOC, of the transformer will consist of the price of the transformer or the value of the offer submitted by the manufacturer in addition to the cost of the losses. Only after considering all of this can we accurately determine which company is offering the lowest cost or which company is the most suitable for purchasing the transformer. Before we talk about how to calculate the cost of losses inside transformers, we will briefly discuss the source and types of electrical losses in transformers. In a previous lecture, I spoke in detail about all the components of a transformer, and we learned together that the main components of a transformer are the transformer tank or the main tank of the transformer, the iron core, the windings, whether high voltage windings or medium voltage windings, and of course the insulating mineral oil that fills the inside of the transformer. As for the types of electrical losses inside the transformer, they are as follows. Main losses and secondary losses. The main losses inside the transformer consist of two types, load losses and no load losses. Load losses consist of copper losses and stray losses. Of course, copper losses result from the flow of electric current through the transformer windings, whether the windings on the primary side, the secondary side, or the tertiary windings, because naturally each winding has a different resistance and carries a different electric current. However, with regard to stray losses, they consist of stray capacitance and leakage inductance. Of course, stray capacitance losses result from the leakage electric field between the different windings, between the windings and the iron core, and between the windings and the transformer tank or the main tank. However, with regard to leakage inductance losses, they result from the leakage magnetic field. However, with regard to no-load losses, they consist of apparent losses and core losses. Of course, apparent losses occur due to the flow of the magnetizing current or the no-load current flowing only in the primary windings of the transformer. However, with regard to the iron core losses, they consist of eddy current losses and hysteresis losses. Of course, the most important factor affecting eddy current losses is the thickness of the iron core laminations. However, hysteresis losses result from the magnetic field and the magnetization process of the iron core. As for the secondary losses, they consist of auxiliary losses and power quality losses. Of course, auxiliary losses result from the electrical energy consumed by the transformer cooling fans, the on-load tap changer motor, and the pumps, if present. And finally, power quality losses, which are caused by the presence of harmonics, resonance, and reactive power. Now we have briefly and quickly learned about the types of electrical losses in transformers. However, we want to understand how we can calculate the cost of these losses inside the transformer. In other words, the presence of this transformer within the substation will result in electrical losses. So, how much do these losses cost over the course of 1 year? This way, we can evaluate the efficiency of the transformer we are planning to purchase. As for how to calculate the cost of losses inside the transformer, we use the following equation. PW equals K multiplied by 8,760 multiplied by C, then multiplied by the sum of Wn dot L plus Wf dot L multiplied by AP squared plus B multiplied by FC. The result is in Egyptian pounds. Let me explain the terms. PW is the annual cost of losses in the transformer in Egyptian pounds. K is the loss factor. It's a dimensionless value. 8,760 is the total number of hours in a year. C is the cost of energy per kilowatt hour in Egyptian pounds. Wn.L refers to the no load loss measured in kilowatts. Wf.L is the full load loss, also in kilowatts. A P is the load factor. Again, it's dimensionless. B is the harmonic loss coefficient, and Fc is the harmonic loss component, usually in kilowatts. This formula helps us calculate the total cost of electrical losses in the transformer over a year, including no load losses, full load losses, and losses from power quality issues like harmonics. PW is the present value of the cost of losses, calculated using a secondary interest rate of 7% over a period of 20 years. Naturally, this cost depends, as we will see, on the current price of 1 kilowatt hour. And since this price will certainly change over time, an annual interest rate of 7% has been applied to account for this variation. As for K, it is the annual interest factor calculated at a rate of 7% over a period of 20 years, and this factor equals 10.594. As for the number 8,760, it represents the total number of hours in 1 year, because as I mentioned, the cost of the losses is calculated over the period of 1 year, that is, over 365 days. And of course, we all know that electrical energy consumption is measured in kilowatt hours, meaning per hour. That's why we multiply 365 days by 24 hours, which equals 8,760 hours in a single year. However, as for C, it is the cost or price of 1 kilowatt hour. As for WNL, it refers to the no-load losses measured in kilowatts, and of course, this is under the condition that the tap changer is set at the principal tapping or middle position. In other words, as we can see on the transformer's nameplate data or the tap changer data for this transformer, it has 19 steps. Therefore, the principal tapping or middle step is step number 10, which corresponds to a voltage value of 66 kilovolts. Also, WFL refers to the full load losses measured in kilowatts. These losses are measured at the principal tapping of the on-load tap changer and under the condition that the reference temperature is 95 degrees Celsius. However, if the reference temperature is lower than 95 degrees Celsius, let's say it is theta degrees Celsius, then the full load losses should be multiplied by the factor 235 plus 95 divided by 235 plus theta. This adjustment ensures that the losses are normalized to the standard reference temperature of 95 degrees Celsius. We see in front of us the nameplate data of a transformer with a rating of 25 megavolt amperes. Of course, through it, we can obtain the no-load losses and the full load losses. As for the symbol A, it represents the load loss factor, and its value is 0.4. However, D represents the peak load in per unit, and its value is 1.1. As for B, it is a factor related to the number of operating hours of the cooling fans, and its value is 0.4. Because, of course, the cooling fans operate only at certain times, especially during peak load periods or high temperature conditions. However, FC is the consumption or load of the cooling fans, measured in kilowatts. Now we have together understood the main equation through which we can calculate the cost of electrical losses in transformers. Therefore, it is required to calculate the cost of losses for the transformer we plan to purchase, and of course, for each offer submitted, whether from company A or company B. Of course, through the technical specifications and catalogs provided by the manufacturers, we can obtain the value of the full load losses, WFL. For company A, it is 140 kilowatts, and for company B, it is 150 kilowatts. As for the no-load losses, WNL, for company A, they are 20 kilowatts, and for company B, they are 25 kilowatts. Regarding FC, which is the power of the cooling fans, it is 5 kilowatts for company A and 5.5 kilowatts for company B. Of course, we spoke a little while ago about the equation used to calculate the cost of losses inside transformers, and this equation appears before us. Of course, as we have understood together, K equals 10.594, and the cost or price of 1 kilowatt hour at a voltage of 66 kilovolts currently equals approximately 1.3 Egyptian pounds per kilowatt hour. Also, P equals 1.1, B equals 0.4, and A equals 0.4. By substituting into the equation before us and using the data from the offer submitted by company A, we can obtain the cost of losses for the transformer in offer A, which equals 10,829,048 Egyptian pounds during 1 year. As for the cost of losses for the transformer offered by company B, it will be equal to 12,040,318 Egyptian pounds per 1 performance year. Therefore, we will notice that the transformer offered by company B will incur losses valued higher than the transformer offered by company A by an amount of 1,211,270 Egyptian pounds during 1 year. Therefore, after adding the cost of losses for each offer or for each company, the total cost of the transformer offered by company A turns out to be cheaper than that of company B by an amount of 1,011,270 Egyptian pounds. This is despite the fact that before calculating the losses, the offer from company B appeared to be the cheaper option. That is why we emphasize that calculating the cost of electrical losses in transformers is a very, very important step when purchasing any transformer. Thank you for your attention. See you in the next lecture.